Viscous force is nothing but the tangential force that tends to oppose the relative motion between the layers of a liquid. The velocity remains constant up to certain limit with which an object moves in a fluid is called as terminal velocity. If RE value is more than 2000, then the flow of liquid is called as turbulent flow. It is considered as turbulent flow. Hello everyone, welcome to session 5 of chapter 10, Mechanical Properties of Fluids. This is Swati from Department of Physics, Vidhyaashram University College, the Temple of Excellence, Mysuru. So in the study of mechanical properties of fluids, in the last class we were discussing about Bernoulli's principle, Torricelli's law, and also the applications of Bernoulli's principle. What are the illustrations where the Bernoulli's principle can be practically applied? So in this study we understood that the designing of the aircraft wing and also the working of Venturi meter and also so many illustrations we have discussed, and also Bernoulli's principle helped us in understanding the cause of heart attack as well, because the Bernoulli's principle states that the pressure and velocity are inversely proportional to each other. In this concept we have understood the blood flow or the cause of heart attack. So in today's session, we are going to discuss about the properties of fluids such as viscosity, surface tension and many more. So what is this viscosity? So look at this picture. So this picture is a picture of honey. So just compare this honey with water. So if you take a spoon of honey and start pouring it and take 1 spoon of water and start pouring it, so we will observe the flow of these two liquids. I mean, which liquid can flow easily and which liquid will feel the opposition in the motion or resistance in the motion of that liquid. So here honey is an example, best example to understand what is the viscosity property of a liquid. So when you compare honey and water, and if ask the question which is more viscous in nature, then the answer is honey. Then what does it mean? So it states that the property of a liquid by virtue of which it opposes the relative motion between the layers of it is called as viscosity. Viscosity is a property of liquid where we can observe the relative motion, the opposition in the relative motion of the layers of liquid, and that property is called as viscosity. So now what is viscous force? This is also an important term. Viscous force is nothing but the tangential force that tends to oppose the relative motion between the layers of a liquid. So viscous force always acts tangentially on a liquid surface. So what does it force do? So this force opposes the relative motion of layers inside the liquid, and viscous force is responsible for the viscosity property of a liquid. So observe these three examples given here. One is water, the other one is liquid with more viscosity compared to water, and the last one is the another liquid which is higher viscous in nature. So now we can see, we can easily pour water. This can fill more when compared to this, and compare these two. Now we can observe the amount of this liquid more when compared to this, because this last liquid is more viscous in nature, and this is experiencing the relative force or the opposition between the layers of the liquid, and hence it will come down very slowly. And since it is a more viscous in nature, we can observe at particular instant of time when compared to these three examples, this liquid is lesser because it takes more time to drop, since it is more viscous in nature. So generally viscosity means a property of liquid by virtue of it opposes the relative motion between the layers of a liquid, and this property is called as viscosity. So let us move on to the another property in the study of fluids, that is Stokes law. So what is this Stokes law? What is the expression for this? So Stokes is a scientist. So it is named after a scientist and hence the name Stokes law. What does it state? So it states that the force of viscosity on a sphere moving in a viscous fluid. So it is given by F is equal to 6 pi eta RV. So this symbol is called as eta, and this is nothing but coefficient of viscosity. When the coefficient of viscosity. So when the sphere is dropped in a viscous fluid, so it will move slowly. What is this force experienced by the sphere? And this force of viscosity is given by the expression F is equal to 6 pi value is 3.14 or 22/7. So where eta is the coefficient of viscosity of the liquid what you have considered. If the sphere is dropped inside a castor oil, then the coefficient of viscosity of the castor oil is considered. If the sphere is dropped inside a liquid called water, the coefficient of viscosity of water is considered in the place of eta. So respective liquid's coefficient of viscosity we have to consider in defining the Stokes law. So it states that F is equal to 6 pi eta RV, where F is the viscous force, eta is the coefficient of viscosity, V is the velocity of the object, and R is the radius of the spherical object. We are defining this exclusively for the spherical or the sphere which is moving in a liquid. So R is the radius of this spherical object. Stokes law is given by F is equal to 6 pi eta RV. So next we are moving on to terminal velocity. We need to know about the meaning of terminal velocity. What is the meaning of terminal velocity? Terminal velocity is nothing but the constant velocity. The velocity remains constant up to certain limit with which an object moves in a fluid is called as terminal velocity. So if the object is dropped to move inside the liquid, it will travel with a constant speed up to certain limit, and that certain velocity is called as terminal velocity. The constant velocity with which an object moves in a fluid is called as terminal velocity. So far we have discussed about the viscosity, viscous nature, viscous force and the terminal velocity. Now we are moving on to the another concept called Reynolds number. There is a significance of this topic called Reynolds number. What is the significance of Reynolds number in the study of nature of flow of fluid? So let us see that it's a dimensionless parameter. Reynolds number is a dimensionless parameter whose value determines the nature of flow of liquid through a pipe, whose value can help us to understand whether the flow of fluid is a streamlined flow or it is a turbulent flow. Expression for Reynolds number. Then how to calculate this Reynolds number? The expression is given by Re is equal to rho Vd divided by eta. So what is this Re? Re is called as Reynolds number. Rho is nothing but the density of fluid or the liquid, V is the velocity of fluid, and eta is coefficient of viscosity of the liquid as I explained in the earlier slide, and D is the diameter of the pipe in which the liquid flow. By knowing all these values, rho, the density of the liquid, diameter of the pipe in which the liquid flows, and the velocity of the flow of liquid, and the coefficient of viscosity of a particular liquid, we will come to know about the value of Reynolds number. So this value helps us to understand whether the liquid is flowing as a streamlined flow or it is a turbulent flow, because the significance of Reynolds number is to give us an idea about the nature of flow. Generally, Reynolds number is denoted by Re. So, if Re is less than 1000, then the flow of liquid is streamlined. If Re is less than 1000, then the flow of liquid is streamlined. In the last session, we have learnt in detail what is a streamlined flow, what is turbulent flow. If Re is more than 2000, if Re value is more than 2000, then the flow of liquid is called as turbulent flow. It is considered as turbulent flow. And what if the Re lies between this 1000 and 2000? What if the Reynolds number lies between this 1000 and 2000? So then we can say that the flow of liquid is unstable. It is neither streamlined nor turbulent. It may change from streamlined to turbulent and vice versa. So if it is less than 1000, then the flow of liquid is streamlined. If it is more than 2000, then it is turbulent. If it lies between these values 1000 and 2000, then we can say that the flow is unstable and it can change from streamlined to turbulent or vice versa. So this is the significance of Reynolds number. So that is about Reynolds number. In the last slide, we have discussed about viscous force. Now let us see what are the factors on which the viscous force depends. What factors on which viscous force depends? So it depends on the area of layer. So it also depends on the velocity gradient. What do you mean by velocity gradient? Look at this expression. It is nothing but dv divided by dx. So dv is nothing but the rate of change of velocity with respect to distance. dv stands for velocity. It is changing with respect to distance. So it is in the direction perpendicular to the flow of liquid and it is called as velocity gradient. Velocity gradient is generally denoted by dv divided by dx, which means the rate of change of velocity with respect to distance, and that is in the direction perpendicular to the flow of liquid and it is called as velocity gradient. So these are the factors on which the viscous force depends. So it depends on area of the layer and velocity gradient. So next we are going to study about coefficient of viscosity. It is denoted by eta, as I explained. So what is this coefficient of viscosity? So a coefficient of viscosity of a liquid is nothing but the viscous force per unit area. It is nothing but viscous force per unit area. So it is acting between two layers having unit velocity gradient. So generally it is defined as the viscous force per unit area that acts between two layers having unit velocity gradient, or it is also defined as the ratio of shearing stress to strain rate. So here you can see eta is nothing but coefficient of viscosity, shearing stress is nothing but force divided by area, and strain rate means the rate of change of velocity. That velocity is changing with respect to distance. Strain rate is given by V divided by X. So it can be written as F, this X goes to numerator, Fx divided by A into V. So it is nothing but eta, and eta is called as coefficient of viscosity. Next concept, surface tension. So it is very familiar to all of us. This word surface tension is familiar to all of us. There are so many practical things which we come across in our daily life which is based on surface tension. What does it mean? It is a property of a liquid due to which the free surface of a liquid tends to have minimum surface area and behaves as a stretched elastic membrane. Suppose if we drop a needle or a pin or a file holder pins on a surface of a liquid, it generally floats. We might have all observed this. Why does it generally floats? Because of the surface tension. The top layer of the liquid acts like a stretched membrane, and hence if you drop anything which is lighter on the top surface can be floated. So the answer for this is surface tension. It is a property of a liquid in which the free surface of a liquid occupies the minimum surface area and behaves like a stretched membrane. If F is the force acting on a liquid surface of length L, then surface tension is given by T is equal to F divided by L. That is nothing but force acting on a liquid surface. It is nothing but surface tension which is given by T. The unit of surface tension is Newton per meter. So the unit SI unit is Newton per meter because it is force divided by L. So if unit is Newton and length unit is meter, so it goes to numerator and you will get Newton per meter. So next we have surface energy. What is the surface energy? So surface energy is nothing but the excess potential energy possessed by the molecules on the surface of a liquid, and that is called as surface energy. The name itself says it is the energy possessed due to a molecule, or the excess energy, excess potential energy that is possessed by a molecule on the surface, and hence the name surface energy. It is given by ES is equal to T into A. What is T then? T is surface tension, A is surface area. So from this, surface tension is also defined as surface energy per unit area. So that is T is equal to ES divided by A. Now we came to know what is surface tension. So let us see some illustrations of surface tension. How can we understand this surface tension? What are the advantages of this property of a liquid? So when a detergent is added to water, it decreases the surface tension of water. Why it is not so easy for washing clothes without detergents? Why it is difficult? What if you wash the cloths or the dirty cloths without detergents? The stain will not remove completely. Why is it so? Because generally the water will be hard. So if we add detergents to the water, it will decreases the surface tension of water, and this helps the water to penetrate inside the threads, which helps in the cleaning the stain of the cloth. So therefore, when a dirty cloth is dipped in soap water, it penetrates to the interior parts of the cloth and removes the dirt. This is how the surface tension plays a role in washing clothes. So if we add the soap or the detergent, it will decrease the surface tension of water. So without the detergents or the soap, the water cannot penetrate into the thread so easily to remove that stain. So if the detergent is added, it helps in decreasing the surface tension. And suppose if you dip your hand in a soap water, we will also feel that the water becomes so soft or smooth when you compare with the water without any soap or detergent, because detergents will decrease the surface tension. If the surface tension is less, the soap water can penetrate into the cloth and it will clean the stain. This is one of the illustrations. So I'll give you one more example. Suppose if the painting brush, when it is dipped into a water, the hairs of the brush will spread throughout. Then if we take it out, what happens? All the threads or the hairs of the brush will stick together. So why it is sticking together? What is the reason for them to stick together? Is because of surface tension. As I already told you, like if the floating pin or the needle is floating on the surface layer of the liquid, that is also because of surface tension. And due to the surface tension of a stagnant water, the mosquito lays eggs on the water. So these legs will also float on the water because of the surface tension of the stagnant water. So these are few illustrations of surface tension. Let us move on to the next topic, that is angle of contact. What is the meaning of angle of contact? It is the angle between the tangent drawn to the liquid surface at the point of contact and the solid surface within the liquid. So it is nothing but the angle between, you can see here, the angle between what? The tangent drawn to the liquid surface. The tangent, here is the tangent which is drawn to the liquid surface at the point of contact and the solid surface within the liquid. You can observe here we are getting the angle of contact means the angle between the tangent drawn to the liquid surface at the point of contact and the solid surface within the liquid. Here this is a solid surface, this is a liquid droplet. If we draw a tangent to it, then we can calculate the angle between this liquid layers tangent and the solid surface. That gives us angle of contact. If the angle of contact is acute, which is nothing but the less than 90 degree, then the liquid is said to be the liquid which wets the surface which are in contact. Suppose if the angle of contact, say for example, the liquid is spilled on the floor. So if I draw a tangent where I should draw? Tangent should be drawn between the liquid layer which is in contact with the solid. So it is a tangent. Now if I find the angle, this is obviously less than 90 degree and it is acute angle. So if the angle of contact theta is less than 90, then this liquid is nothing but it wets the floor because it is in contact. Suppose if the angle of contact is more than 90 degrees. Consider a mercury liquid drop. So let us write the tangent for this. Tangent should be drawn between the liquid surface which is in contact with the solid, and here we will get the angle. So here in this example the theta is more than 90 degree, which is nothing but the obtuse angle. So in this case the liquid does not wet the surface. We know mercury droplet, the angle of contact is obtuse because only a middle of this surface will touch with the solid surface. So if we draw the tangent to it, we'll get obtuse angle which is more than 90 degree, and this type of liquids are called as the liquid that doesn't wet the surface. This is the significance of angle of contact. It is not like angle of contact should only have 90 degree or 180 degree. It can have any value between 0 degree and 180 degree. The angle of contact between ordinary glass and ordinary water is acute. So if you consider ordinary glass on which the water spilled, then it wets the glass because it will get an acute angle. The value is about only 80 degree. So the angle of contact between mercury and any surface, as I have shown, mercury, if it is dropped on any surface, the angle of contact will be obtuse. So it is about 135 degree, and hence it doesn't wet the surface. The drop just touches the surface, it doesn't wet. But what if the water falls on the glass surface? It will spill and it will wet the surface, and it is acute. So the angle of contact between smooth glass surface and pure water is 0. If you consider a smooth glass surface and a pure water, then the angle of contact is 0. So the next property of liquid is capillarity, or we can also call it as capillary rays. What is the meaning of capillarity or the capillary rays? What are the illustrations? The rise and fall of a liquid in a capillary tube immersed partially in a liquid is called as capillarity. Capillarity means the rise and fall of a liquid inside the capillary tube when it is partially inserted or immersed in a liquid, and this is called as capillarity. So it is due to the property of surface tension. What is the meaning of capillarity tube? We might have all observed in our practical labs that we are having a capillarity tube which is having a fine bore. So this tube will be like this, inside which we will be having a fine bore like this. This is called as bore. This is called as capillarity tube. So inside this capillarity tube, so if the liquid rise or fall when this tube is immersed partially inside a liquid, this property is called as capillarity. And why this property? This is due to the property of surface tension. So capillary tube is nothing but a fine bore of uniform diameter. So if you consider this bore, the diameter will be uniform throughout. And this is called as capillarity tube. You can all observe in your practical labs as well. So the expression for capillary rise of a liquid is given by H is equal to 2T cos theta divided by R rho G. What is this H? H is nothing but the capillary rise, and generally H is a letter which is used to denote the height. So rise means, capillary rise means the height of the liquid. So T is nothing but the surface tension of the liquid, and R is the radius of capillarity, and rho is the density of the liquid, and G is acceleration due to gravity. Theta is nothing but the angle of contact. So knowing all these terms, the T means the surface tension of the liquid, then theta value, that is the angle of contact of liquid, and radius of the tube, density of the liquid, and acceleration due to gravity is a constant. Knowing all these values, we can find the height or the rays of capillarity inside the capillary tube, or we can find the capillary rays of a liquid. So next we have illustrations of capillary rays. Look at this diagram. So we have all observed this also in our life. What is it? So when the candle or when the wick is illuminated with a light, so what happens? The oil which is there present inside this lamp, it will spread throughout the threads of the wick. The wick will absorb the oil, and hence it helps in glowing the light here. What is the reason for why? How can it absorb? So it can absorb due to capillarity. Oil rises in the wick of an oil lamp due to surface tension of the oil, and the pores in the wick acts like a fine capillary tubes. This is the reason behind the absorption of the oil, because the threads in the lamp will act like a fine pores, and it will absorb the oil, which helps in illuminating of light in the lamps. So next we have water in trees and plants rises upward through fine pores of roots, and that is also because of capillary rays. If we pour water to the roots, the plants will absorb this water and helps in transportation of water to the tip of the plant. That is because of capillary rise. So how does it happen? That is through the fine pores of roots, and that because of capillary rays action, the water will be transported to all the parts of the plant body. So next is sponge absorbs water and the blotting paper absorbs ink by capillary action. So pour some water on the sponge, it absorbs immediately. That is also because of capillary action. And if you place a blotting paper on an ink, it will absorb immediately. The few examples which we come across in our daily life, and from this properties of liquid, we are now able to answer the reason for all these actions. So these are the few illustrations or the principles or the properties of liquid we have discussed in today's session. So in the next session, we will discuss few more interesting concepts. Until then, all of you please take care. Thank you.